Yes, solar radiation. Yeah. So all of you note down this problem. We'll solve another two problems in this session, and we'll wind up that NCS first chapter, and later we'll go for the other syllabus. Okay. So this problem, the question you can see here. This is about the estimate the average global radiation. All of you recall the meaning of each word so that one can understand what equations we can use and solve this problem. So all of you can see the problem, I think. Given problem, all of you can see.
Yes, sir.
Here they have given the place, one place is given Baroda. On horizontal surface, they have taken the readings on which the location is 22° north. So 22° north is the latitude. Angle phi is given here directly. Then 73°10' east is the longitude. That is also given as per the location is concerned. During the month of March, if the average sunshine hours per day is 9.5. So average sunshine hours, what we are taking as S, small s, or here they have given N, small n. So different books have given different notations. We'll not bother about that, but we'll understand the problem and the notations, what we are using for our problems, and we'll try to solve the problems. Okay. And for this, they have given assume constant A 0.28 and B 0.48. Also assume H naught equal to H naught bar. So if I read complete question, here first thing is we need to find out average daily global radiation. So whenever we say average radiation, that comes under monthly average. This is the first part, what we need to understand. Monthly average we need to find out. Next is daily global. Daily means we are going to denote it by H value. Hg denotes global, means it is sum of beam and diffuse radiation. So all together they are calling it as monthly average or generally average daily global radiations. So it is nothing but Hg, and in the assumption they have given H naught, you can consider it as H naught bar. So I'll consider this whole equation for the monthly average, not for the daily average. I hope the point is clear. So once they told to consider bar as a average, then I will take Hg bar as the given or the question what is asked, Hg bar. So coming to this problem, we know AB constants, we know sunshine hours per day, average sunshine hours 9.5, means S is known, AB is known, and they are telling some H naught and H naught bar values. So keeping this in mind, and Hg bar I think they are asking to estimate. So keeping these all terms in mind, I think you can recall our global daily average for a given month. That equation we can recall here. So this was the equation we have discussed in the class earlier, this equation, or this H naught bar considered. If H naught is considered, this is the equation. So in this equation, constants A and B are given. Hg itself denotes monthly average daily radiations. H naught denotes extraterrestrial radiations for the given month. And S bar, as per S bar is concerned, it is sunshine hours. S max bar is what? S max bar is, you can find out day length if you want, or else maximum sunshine hours. If you know the correlation, you can find out. But here, better to go for the day length for our convenience. As per the earlier problems what you have solved, we can take the daily day length, assuming the complete day was with the sunshine, and we can take the maximum sunshine hours. Okay. So I think all of you understood the problem and which equation we have to go for. So now we'll see what is the next step. So here we need to find out day length Okay, we need to find out H naught, and for H naught, the monthly average extraterrestrial radiation, we have the correlation. So that correlation is what? Again, recall the earlier problems. You can find out H naught can be found out by this equation. That is H naught equal to 24 by pi solar constant into this bracket. Okay, so in this bracket, if you just focus, we can find out nth day. So nth day, actually it is not given here in this problem. It's very important because they have told only March. Which day they have not told. Solar constant we know. Hour angle we need to find out. Latitude is given in the problem. Delta we need to find out by using this n value. So once you find out these unknown values in this formula, one can find out what is H naught bar. Or once you can find out H naught, that itself can be considered as monthly average. And before solving this problem, even in the explaining about the equations or the correlations, I have told you this average or the monthly average values can also be considered for one of the midday of the month. Do you remember? If I take April or any January, if I take 31 days are there in the month, one can consider if all the days were clear sun or with the completely cloudy month, in that we can consider one of the midday, like 15th or 16th we can consider, and that itself we can, or that itself represents the average value of the given month. Anyone remember that? What I explained in the classes? Yes? That's why in the question they have given, you can assume, see here, in this PPT what they told, H naught you can take it as H naught bar. Why? Because in that given day of March or in that month of March, whatever H naught value you find out, consider this itself as average. Means what? They have given one of the midday you can consider and you can take the average. Now which midday we need to consider? That is very important. So if you go back to given data in the books or some other reference I have taken from Sukatme here, in that book what they tell is you can consider a midday or the middle value of that month as an average, which indicates the monthly average solar radiation of that month. Means one day if you measure, that is enough. That itself represent a complete month. So we'll see that which day we'll consider for the March. So here they have told Klein has given some correlation. What he told, determine particular day in each month on which the extraterrestrial radiation, that is H naught, extraterrestrial radiation, is nearly equal to that month or monthly mean value or the average value. So which days he told? So all of you can write down these numbers. Okay, which day of the given month you can take it as a representer day. For example, January, he told 17 you can consider. February, you can consider 16. March, you can consider 16th day. April as 15th day. So like this, you can consider many middle days which represents this average H naught value or H naught bar value. So for this our problem, we'll consider March 16th as the representative of monthly average global radiation or the extraterrestrial radiation. I hope the point is clear. Now, which day we need to find out for the March 16th? Because, but in the problem, they have not mentioned. So even though if the problem, they have not mentioned the day, for this monthly average, you need to remember these numbers. So it is not important for NCS students, but still, once you know these numbers, even though if it is not given anything in the problems, you can just take the numbers as per this given representing days and you can substitute and find out the unknown values. Any doubts up to this understanding the question given? All of you understood the question? What to be done in the solution? Any replies? Shall we continue? Okay. So now we'll see the solution. So all of you understand the procedure, how to solve the problem. In between, you can tell me the answers from the calculator. Whether the answer given as per this solution is correct or not, we'll just tally it. Okay. So I hope all of you understood the given problem. It is similar to our earlier problems, what we have solved. So, but those who are absent for the earlier class, you can just understand this. So just assume this equation is hg bar by h naught bar equal to a plus b into s bar by s max bar as per our correlation what we have discussed in the classes. Next. So now we need to find out this h naught. So before going to this h naught, we need this n value. Solar constant is known to us. We need hour angle, then latitude phi or lambda. A declination angle is required. So for this, what we'll do is we can go one by one. So declination, all of you know. Assuming for the March 16th, see here, 16th they have taken for the March. So for that March 16th, what is the nth day? So earlier also you have calculated. January 31 we are taking, February 28 and March 16th. Because March 16th, see here, March 16th represents the monthly average value itself. So we are taking March 16th because other than that we cannot find out the angle of declination. That's why. So here we have taken 16 or that person has taken 16. The author has taken 16th March and he found that nth day of that year is 75. So he substituted and found out the declination angle minus 2.42 degrees. So please one of you can calculate and tell me whether this is the correct value or not. Because later we should not get confused with the different answers. If this answer is wrong, we'll take that correct answer and solve for the next step. So if declination angle is minus 2.42, then we can find out the hour angle. Because latitude is known, declination angle is known, one can find out hour angle. Or you just recall all the equations required for our problem. One by one, whichever is unknown, we can go by those equations. Is the answer is correct?
Yes, sir. Yes, sir.
Okay. So if minus 2.42 degrees is correct, then that same value will substitute in the hour angle equation. So that is cos inverse of minus tan phi tan delta as per our notations. So tan phi is given without any minutes and decimal points. See here, latitude is given directly 22 degrees. So phi value will take 22 degrees, tan of minus 2.42 degrees. So both angles are in degrees. So our angle will get in degree, 89.02. Okay, so one can check this answer. And now using this hour angle, one can go for the day length. Because day length, we know the formula here. Directly you can find out either day length by other equation also. By this equation also, not an issue.
Sir, 89.202 is correct.
Okay, thank you. 89.02 is correct. Then, see here. This was the day length. What?
Go, sir, please go a bit slow, sir.
Okay, right. I thought many were. Yes. I thought last class we have solved such problems, so I can go first. Okay, I will reduce my speed.
We are noting down, sir.
Yes. Someone is telling something, or can
we are noting down problem, sir. We are noting down problem.
Okay. You're noting down. Okay. Question you have noted down?
Yes, sir.
Okay. So which step is over? You tell me. We'll go to the next.
Sunrise hour, sir. Sunrise hour. Now, please show sunrise hours later.
Sunrise hour. Okay. And one more thing, in the NCS Google Classroom, I have shared today this NCS notes, short notes I have shared there, which covers maximum syllabus. 95% syllabus is covered in that. But important is, with those notes, you have to make it in detail while writing IA test or the exams. Okay. So with that notes, what you can do is you can refer either JD Rai non-conventional energy sources book or Sukatme for solar energy or any other book also, like Domkundwar is there, Shawnee is there, then we have Garg and Prakash is there, Rajput is there. So many books are there. But important is, as per that NCS syllabus topics, I have prepared that notes earlier in VTU. Same syllabus is continued in our autonomous also with very small changes. So that notes with some books you can refer for the detailed explanation in exams or IA tests. And that will cover 95% of the given syllabus points. That
Okay,
is
sir.
one thing. One more thing what I want to tell you is elective list is still not finalized as per the committee. So when the elective list is finalized, I will go through your course activity reports. Okay, I'll just note down which reports are good and whatever is done. Later we'll consider that part for any other requirements. Is that clear? We'll not allow that to go as waste. We'll consider that in somewhere in the our course. And those who are not prepared, after completion of that or the finalization of the elective list, please complete that work, that course activity work, which I had given in the earlier, because that will be important for our IA test and assignments. Okay, any doubts about the subject? How to go about the subject and other things? All are clear, no? Okay. So now come back to the problem. Okay, sunrise hour angle, have you noted down?
Yes, sir. Yes, sir.
Okay, okay, thank you. So now sunrise or omega hour angle is known. Then we know the declination angle. Then one can find out the day length. So day length equation is known to us from our theory discussions. That is 2 by 15 cos inverse of tan phi tan delta. Same equation we'll use. Only thing is what they have written. In place of cos inverse this tan phi tan delta, they have written omega s. Or you can take the full equation also, this full equation. Both are same. So what they have done, 2 by 15 into cos inverse of tan phi tan delta. That they have taken in the equation. So taking this omega itself as a value, they have substituted and found the day length. Now day length indicates on March 16, the sun was on the sky from morning to evening for 11.87 hours, which is actual sunshine hours for the given day or the maximum sunshine for that given day, assuming that complete day was with clear sunshine. I hope the day length point is clear to all. What's the meaning of day length? Now, you can recall or can just imagine this equation and you can just check all the values are found out or not. The nth day of the year is found out. Solar constant is a standard value. We know. Day length is found out. Sorry, hour angle is found out. Sine of phi, the latitude angle, lambda or phi is also given in the problem. Delta, yes, we have found out delta. Declination angle minus 2.42 degree. Phi is also known, delta and hour angle. All values are known to us. Now what we can do is, now we can go for this next step. What is that? H naught. Once you find out this H naught value, then we can assume this March 16th monthly average daily extraterrestrial radiations H naught is equivalent to same month average daily global radiations or the extraterrestrial radiations. If I tell globally, it is wrong. It represents what? H naught bar, monthly average extraterrestrial daily radiations on a given horizontal surface. So I can assume that as H naught bar because I have taken the middle of that month, which represents the monthly average. So we'll find out H naught and we'll write it as H naught bar. So substitute all the values what we have found out in the given numbers and find the H naught value. Now, can anyone tell me why that hour angle is multiplied with pi by 180? What is the need? How much is the answer? (24 by pi 1353) 1 plus 0.033 cos of 360 into 75 by 365 omega sine 22 sine of minus 2.s cos of minus sine of 89.02. Yes, 24 by pi. Check all of you are getting 11,911 value. Now the unit of this H naught depends on the solar constant what you have taken, 1353. So can you tell me the units of that solar constant written in 1353? As per that unit, what is the unit of this H naught? Because he has not written the unit here, but we need to write. Day length on particular day in every year. No, that also depends. Yes, Vishwa Hiremat is asking day length on particular day in every year. For example, today September 22, September 22, 2021, if I take, day length will be differing little bit. It will not be exactly same. That's why here we are doing all the calculations with these constants and correlations only. That is one thing. And here in the such problems, as I told, many times they'll not mention the year. In this problem, if you see, they are not mentioned the year. Can you see there? They have not mentioned the year. So we generally take some standard values. March 16, like a regular year. If same question is asked for the leap year or some different years, something like that, the value may be differing. And depends on that February month also. I hope all are understanding. So little bit change will be there with the day length value also. It may not be same. Yes, BH Khan you can refer, but I feel some topics are very uh, treated with some different concept. That is one thing that you should be careful. You can refer BH Khan, not an issue. But some topics are not available in BH Khan. Considered with the GD if you consider, some topics are not available. And some topics are very good in BH Khan also. But day count will be same, sir. Yes, that's what I'm telling you. These all equations what you are using, these all are correlations only. Day length and other things, same you are taking. So that whichever the year is not given, we are assuming that is the extraterrestrial radiation and the global radiation on the Earth surface. But if you consider exact given year with the latest, what I told is latest correlations. Say for example, 2020th, if one researcher has done, which is giving more accurate results. And nowadays, if you see 2020 and compared to 1990s, the diffuse radiations are more nowadays because of the more pollution. So global radiation average will also change now nowadays. So actually we need to consider all those factors. But here in the problems, we are considering those correlations which are accepted in all the different books until that edition. So this only I discussed in the earlier classes. So whatever general consideration is done for all the syllabus and other problem solution steps, that standard procedure we are following. That's all. But latest, if you want, you can find out 2020 research papers and you can find out these actual correlations with accuracy, with more accuracy of the results. But that should be validated only after the measurement only. Once you measure the solar radiations, it can be validated how much accurate it is, giving with the different equations, latest equations. Okay. Yes. So all of you have taken this H naught value.
Yes, sir.
What is the unit? 11,911. What unit we need to write? Is it watt per meter square day or kilowatt per meter square day?
Kilojoules per meter square.
Yes, kilo.
Joules per meter square.
Yes, only joules per meter square. Yes, because either you can consider this as watt per meter square day or joules per meter square day. Then you can go for this as watts only. Because here we are not writing 1.353. If I write 1.353 as solar constant, this will become in kilowatt or kilojoules. So then you have to take the same units of this solar constant substituted value. Okay. So now coming to the main equation, what is required for our problem? That is Hg bar by H naught bar equal to A plus B into S by S max bar. So substitute all the given values now. H naught is found out 11,911. Constant A is given, constant B is given. S is also given 9.5. N is also, S max is also given 11.87. So S max, what we have done, we have found out the day length, 11.87 hours. So take all these values. These are the non-dimensional numbers. 0.828 is a constant, 0.48 is a constant. Hour by hour is a constant ratio. This you are going to multiply with H naught value, which is in watt per meter square day or joules per meter square day. Then you can find out the Hg bar. So that is shown here. So estimated monthly average daily global radiation Hg bar is 0.664 into 11,911. 11,911 is H naught bar. So approximately we are getting kilojoules per meter square. Or if you want, you can write it in joules per meter square also. Yes, all of you taken the values? Yes, what should be the unit? Again, come back to the unit. We have taken solar constant watt per meter square day. 11,000 we have found out in watt per meter square day. Then here if you see, they have written kilojoules per meter square. Which unit we have to take? Any replies? Whether it should be in watt per meter square for the given month or in kilowatt. Why kilowatt? Because here if you see 0.664 is a constant. This value we have taken watt per meter square for a given month. For a day, if you consider without hour, I can tell it as watt per meter square day, one day. Then if you consider for average H0, I can write it as watt per meter square day, watt per meter square. Once you multiply watt square with this value should be in watt meter square only, not kilo. So this you need to change it in the solution. It as watt per meter square for the given. Yes or no? Okay. So next same type they have given with different location. This you can take care. You can just note down the given values. You can do it as a homework. Calculate the day length for Mumbai on December 1. If latitude is this much, declination angle is given. Just find the day length. So this anyone can do it. Next, what there is a question. Find solar altitude angle alpha at 2 hours after local solar angle on 1st June for place located at 26.75 degree north latitude. Also determine the sunrise and sunset hours as well as the day length. Yes, this you note down. Next to that problem, you just note down. Find the solar altitude angle alpha at 2 hours after local solar angle on 1st June for place located at 26.75 degree north latitude. So latitude angle is given. Altitude angle, what you have to do? After local solar angle or the local apparent time, 2 hours after that, we need to find out for 1st June. Also determine the sunrise and sunset hours. So exact time of the sunrise and sunset hours as well as day length. So these all values we need to find out. Have you noted in this? Tapan Kulkarni. So many people are not attentive to the classes. When I start asking something, they will leave the meeting. Muralidhar. Okay, Viray and Viresh, have you taken down the question? Okay, once you have taken the problem, just go by the numbers. 1st June, find the declination angle. How much you are getting. So for the 1st June, they were again taken the normal year here. So many problems they have not mentioned the specific year. We don't know which is the leap year, which is a full year. We are not clear. So we are always taking the same numbers for the given months. 31, 28, 31, 30, 31 like this. We are continuing. And for 1st June, it is 1. So nth day will be 152. So from that, they are finding it. Now here coming to the solar angle or the hour angle, what they told, 2 hours after the local solar angle. Is that clear? So hour angle, what they have done, they have taken for 2 hours. So for each hour, we know that it is 15 degrees. For 2 hours, how much it will be? 30 degrees. So 30 degrees after the solar angle. Then you can find out altitude angle by this equation, which we have taken in the discussion, or else you can find out zenith angle. You can take 90 minus theta z, that also can find out. So either you can go by these equations, any of these equations. These equations, theta z 90 minus alpha, or find out cos theta z from these equations, or this equation cos theta z you can find out. Then you can find out alpha also, or else take the alpha equation itself. So that alpha equation they have written here in this problem. Sine of alpha is given by sine delta, sine phi sine delta, then cos phi cos delta cos omega. By this also one can find out directly the altitude angle. And altitude angle can be written sine inverse of 0.553. So around 30 degree zenith angle will be there. Around 70 degree altitude angle is there in the same normal plane or the vertical plane. So now you come to the day length. So here altitude angle we have found out. Then determine the day length is over. After day length we'll find out the sunrise and sunset hours. So this is the special case of this problem, sunset and sunrise. At what exactly time, local time, the sunrise and sunset is happening. So find the day length in a similar way of earlier problems what you have discussed. Then we'll find out the sunrise and sunset. So earlier I told you for the forenoon sessions or the before 12 a.m. we can consider the sign of that angle as negative. And afternoon sessions, whatever the sun path is there from 0 to 90 degrees afternoon, that we are considering positive. Is that clear? So now what time we have taken is, see here, total day length is 10.4 hours for the given day. The the sun was shining on the sky for 10.4 hours. In that afternoon and forenoon, if you consider, I can consider as half. Yes or no? So that half, if I consider, that will become part of the morning day length. Another part of the day length is in the afternoon. So by taking that half, what they have done, they have taken 12 minus because it is forenoon, sunrise time. So 12 minus that much of time, if you consider, I can take that value as the sunrise time. And sunset time, what they have done, they have added, because it is after 12, we need to add, or as per sign convention, afternoon we have considered all the values as positive. So positive number of hours, okay, where the day length was half, that time if you add, it will be around 5:12 p.m. So just check these times, whether are you getting 6.8 or whatever 5 value is there. From that you can convert that into AM or PM values. So 6.8, what you can do is 0.8, you can divide that total 1 hour into 8 parts, or you can divide into number of parts, then later 10 parts or what. For 8 parts, what is the time? That you can write it as 0.48, like that. So here exactly time is not given, they have given the angles earlier. Our angle is given. That 30 degree they have given in the problem. From that basis, we are taking the time. Have noted down sunrise and sunset angles. Okay. So next also zenith angle you can find out, not an issue. So we'll skip this part because already we have considered delta angle and cos theta z. In earlier problems also we have solved such problems. So this another problem is there. I think for the NCS students, this is not an important or required problem for our NCS syllabus. We'll take this problem in the solar subject. Okay. So from the next class, we'll go for the other topics of NCS and we'll focus less on solar now. Means solar problems will focus less in the next problem, next classes. Okay. So we'll stop here. Okay.
Thank you, sir.
Okay, thank you.